Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to be taking a look and repairing this Distar Apple II floppy drive. If you watch my channel, you know how much I love Apple II clones, and this drive is just a clone of one of the Disk 2 disks for the Apple. Probably was a lot cheaper when it was new, and it's broken. We first looked at this disk drive in a Super Mini Mail Call episode on the second channel, where I received these two disk drives plus a bunch of other Apple II stuff, and I quickly tested both disk drives, and this one didn't work. So in this video, I'm going to get this disk drive working, and I'm going to do it entirely using this cheap oscilloscope multimeter combo unit. I want to show that even working on things like floppy drives, you don't need fancy equipment, and something like this works perfectly for that. And I will let you know that I'm recording this intro after I've already done the work on this disk drive. And well, this disk drive was A, very broken, and B, I almost gave up on it a couple times. But in the end, I got there, and it's going to make an interesting repair video. So without further ado, let's get right to it. So the label I have on here from when we did the diagnosis was causes both drives not to work. Pretty self-explanatory. There's the front of the drive, the Distar Drive 1. Yep, I guess this maybe was used with a 2-drive setup. And on the hard-to-read label on the back, Distar Incorporated, 2290 Ringwood Avenue, Unit F, San Jose, California. 5¼ floppy direct drive, model LDD-103SSA. Opening this is probably just as easy as taking out these 4 screws. So my assumption on what's wrong with this is that when this was connected originally, or at some point in the past, someone had the pins misaligned. And when you do that, it sends 12 volts into the controller, and that damages chips. Very common affliction. And hey, you know what, actually, look, that's interesting. This QC sticker, I can feel there's a hole there. So that's obviously for a speed adjustment of some kind. But yes, common affliction with these old Apple II drives. When Woz designed the Apple II disk controller, the pin header that was on there wasn't shrouded. So without the shroud, you could accidentally plug this in the wrong way, or you could have it offset a number of pins, and that would cause issues. All right, that came off relatively easily. DDF5 21C 34C, that is not the manufacturer of the entire disk drive. That is just the Japan servo company. They're the ones who made this motor and the speed controller, because you can see Japan servo down there. Getting this out should be as simple as just sliding it out of the chassis. So a few observations about the way this thing is constructed. It's a little bit different than the MyTac drive we looked at in the Super Mini Mail Call episode. This appears to be a track 0 sensor. That's what I'm thinking that is. And you see that notch right there? When the head moves all the way there, I think that actually breaks a beam, which allows it to sense that it's at track 0, so you don't get the head bang, which is a nice improvement over normal Apple II disk drives. Looking at this analog digital board, it is highly simplified, and that's pretty cool. LDD 103 is written on there as well, including an H logo. I like the zip tie to keep the ribbon cable from coming off, because one of the issues with these is this just sticks through the back of the drive, and with a good yank, that could remove this, and then you obviously won't have a working drive anymore. Now the PCB has ICs from around 1984, at least that one is. These are date codes I can't decode. Same with that. This is 1983, and that one is actually soldered down. And this is 1983 in a socket. This IC, this Motorola 3470, is probably part of the differential amplifier, and this will kind of align the circuit. Looks like you have a few test points there just for testing, not that we have any kind of data sheets here. And up at the top here, we have a TBP 18SA030. I couldn't even tell you what that is. This inductor used to be glued down. You can see the glue floating around there, but that has since come free. But that's not going to be causing our problem again. Everything else looks okay. I don't see anything that seems destroyed. All these components seem fine. There are 2 headers on this that interconnect the top board down to the lower speed control board or boards. Oh no, it's just a connector. Okay, so one of them is for the stepper driver and the other one goes to the speed controller. And this board is what controls the speed of the spindle. And look, we can see here, we got some corrosion. So there's probably going to be a capacitor on the top side of the board that has spilled its guts. That is not looking so hot either. Wow. So those caps have done a number on this board. And there as well. Oh dear. Okay, so I'm going to spend a moment here just to try to access these fasteners. We'll see what type of fastener it is. Hopefully it's not filled with glue from holding the label down. All right, good. That's just a normal Phillips head. And hopefully I don't have issues getting that out like I did on another previous repair on another floppy drive. I don't remember which one it is, but I ended up stripping one of the screws because it was so stuck in there. I think it's not uncommon for those fasteners to be held in with thread locker, which just makes the repair that much harder. So fasteners are exposed. They look okay, not filled with glue. Let's try to get these out carefully. Okay, that one is free. This one. Okay, good. Nice little crack sound. And the last one. Okay, good. Yep, all of those came free without too much fuss. Sorry, you can't see what I'm doing. Right, fasteners out. This should lift off. It's going to have some magnets on it. Yeah, I just have to kind of break that magnetic force because, well, I don't know. There must be coils on the backside maybe that it was attracted to or something. Got a little bushing there. So I've got to remember to keep that, put that on. Okay, so we have a couple more fasteners on this board, which I'm going to try to get off without damaging. There we go. That one is okay. Now, what's kind of scary about this is that I'm pretty sure this Japan servo company made the speed control board on my MyTac drives as well. So this may be an affliction that those have as well with the capacitors. This fastener, by the way, was longer than the rest. You can see it's got a little spot there to, I guess, ground the PCB to the chassis or something like that. The rest all seem to be the same, kind of little short, fine pitch threaded screws. All right, so that should stay behind and the PCB should lift out. Okay, here we go. Now we can see what's holding this in. There's a little flat flex there. Glad I didn't yank that and damage it. Can I unplug this? I think I can unplug this. So we can at least lift this up to kind of see what's going on under here. And you have to be careful of these coils. See, they have little flying leads that connect up to the main PCB. I think these are Hall effect sensors for speed sensing. Got various bits of glue there, an IC, and our leaking culprit caps. Evil things, evil. Oh, and look, it even corroded the metal a little bit where that cap was leaking. Rude. All right, so from a cap perspective, there are 5 small caps behind here. Over on this end, looks like one electrolytic. It's around there. That leaked as well. And then we have another electrolytic there. It's leaking. Damaged the board a little bit. And then we have a row of caps there. They might be different. I don't think those ones have leaked. Then we have one there that definitely has leaked. Sort of the little black ones are the ones that seem to have leaked. The blue ones are probably for the 3 phases. So that's the speed controller for this 3-phase motor. So the black ones have leaked, blue ones not so much. First step to when you're fixing something like this is to make a little map, mark down all the capacitors, where they are, the polarity, so we can find the replacements, but also when we go to replace them and put new ones in, we won't be guessing as much. I decided to desolder that little flat flex there just because it's going to be hard to even read the values off these little tiny capacitors. It's better to take a moment to do that than risk breaking it. Now I'm just going through and removing the caps. And it's very fishy smelling. So they're very bad, these capacitors, very, very bad. All right, the map is done. I miswrote a few of the values. I had to check with the magnifying loop a few times just to make sure I had the right values. 4.7, 4710, 3325, 2210, 2210, 4.725, 0.4750, and 4.735. Now the issue is there's a whole bunch of crap on the board here, so I need to try to clean this up. And I think to facilitate that, I'm going to use my little Dremel with the polishing bit, try to remove some of this corrosion, expose some of the copper, hopefully, and if not, I have to rebuild these traces. Oh, the battery is dying on this thing. I guess I should charge my jank life more often. Well, I was doing a good job until it decided to stop working. Let's charge this. All right, there we go. After some rebuilding, this thing has been recapped. At least this board has. Now, the most damage was over here in this area. I ended up having to bend the leads of the capacitors to sort of make the connections. Everything was actually connected, but you could see that that one trace under those legs quite eaten away. So I just went ahead and reinforced it with the bent over legs. Same over here. Everything else, some of them I reinforced with some extra solder, but most of them were okay, like these traces over there. And I covered it up with some clear lacquer, which is what you can kind of see on there, even though that has already dried. Over here, everything was pretty much in fine shape. There was a bit of corrosion in that area where I just re-tinned it. No issues there. And on this end, there was a little bit of corrosion, but no problem. I just bent that one leg over, so everything is making a good connection now. This was the connection to that little flat flex ribbon cable, which I've reattached, and then this capacitor there is also reattached. It looks like it might be bridged, but it's not. That's just some of the flux in between those pins and a little bit of lacquer just to cover up the exposed copper. Now, one thing you have to be careful about when you recap these is the caps were all really low profile. Here are the original caps. So a couple of them, I just didn't have the low profile caps. I had to bend them over. So I think there was one over here and maybe one over there that's bent over, but no big deal. There's plenty of clearance under there now. So I think I can reassemble this thing. And I will add, I'm just getting these shims lined up here. I will add that this particular problem had nothing to do with the fault that this drive has where it stops the other drive from working. If this drive had worked, the digital side of it, well, obviously when it would go to turn on the spindle motor, that would not have worked. I don't think it would have been turning and spinning at the correct speed. So this is going to be a little bit of a trick. You got to drop it down in the right spot because the magnets really hold it down. There it is. These are tapered screws, so it will kind of center this thing. I'm just going to put them all on very loosely first, and then I'll tighten them down. Nice even torque. Not that I think it matters that much, but just in case. All right, there it is, reattached. And we still have enough of the sticker on the 60 Hertz side so we can adjust the speed. The potentiometer, where was the potentiometer? This was the potentiometer right there. There's just a little flat blade screw you would stick through that hole and you would be able to adjust the speed of this thing. And I'm quite sure that's where the hole was, right here under this QC sticker for adjusting that speed without taking the drive apart. So I've been thinking about what's the best process for trying to troubleshoot this board. We know the problem is almost certainly in this section of the board, since this is what communicates to the computer through the ribbon cable. This section of the board is definitely the analog section responsible for the reading and writing from the heads. Now the thing is, we know that's not going to be the problem, right? Because it seems that when this drive was connected, no drive on the machine, on either of the ports on the controller, seemed to have any signs of life. Like we didn't even get the activity LED turning on. That would lead me to believe that there's something to do with the enable signal that is causing a problem. Now the enable signal that turns on the motor and basically activates the disk drive is separate for both of the drives that are attached to this. All the other signals are in parallel except for the drive enable signal. And I went and found a pinout of the various disk drive controllers for the Apple IIs, and here are the various signals. So drive enable on the types of controllers that have two drive supports via daisy chaining, like the Unidisk or the Apple II GS, it's both pin 17 and 9. And on the 2GS, where it supports 3.5-inch floppy drives, is also a 3.5-inch drive select output. So this, in combination with these two signals, allow up to 4 drives, but on the regular Unidisk, which is on the Apple IIe, you have just two 5.25-inch disk drives. And then the Apple IIc only allows one single external drive to be connected. Anyways, for the Disk 2 controller, which is the one we're talking about right here, we don't even have 2 drive support. Well, we do, it's just via separate connectors. So the drive enable signal happens to be pin 14. Now I started going to try to figure out how these signals connect up to the drive. Then I had a thought, that's probably not the best use of my time. I should probably just think about what the problem is. So I went and found the schematics for the original Apple II disk drive. This is what's inside the floppy drive itself. And I figured that basically the drive we're looking at here is going to be somewhat similar. It's not going to be exactly the same, but it will be similar. And if we take a look at these two ICs, 3470 and 3146, those two ICs are right on the drive here, 3470 and 3146. And if you take a look at what's happening on this section, this is the read-write head. So it's just like I said, those two chips are responsible for all that section. And I don't think we have a problem there, at least not that we know about. I think the first thing we should be taking a look at is the enable signal. We need to look at exactly what that's going into. See if we can trace that, because I think maybe if there's something going wrong with this signal, like say it's just shorted to 5 volts or ground, then maybe that's affecting whatever chip on this board drives that signal. It didn't seem to damage this board, because when I unplugged the disk drive, the drive that was plugged into drive 1 was working again. I had this not working drive plugged into drive 2. but perhaps whatever's going on with the enable signal is causing some kind of issues on here. And the reason why I say that is because if any of these other signals were problematic, I don't think that necessarily would keep the other disk drive from working, because normally the enable signal just goes directly to the motor, turns that on. The activity LED goes through a 560k ohm resistor, it comes down here, there's hooked up to a transistor, and the gate of that makes its way to that, and it's joined up to the enable signal. So the enable signal is what turns on, well, through these two ULN 2003s, the gate on this transistor, which hooks up to 12 volts, that activity LED, and then the erase head, of course, that's controlled by a little separate circuit down there, but that allows that to actually work. And it also goes down here to write requests, I don't know, a bunch of other stuff. So that enable signal, which is pulled up to 5 volts all the time through this 1K resistor, this is on the original Apple II disk drive, it does quite a bit. But this goes into the ULN 2003 on a bunch of different pins. Pin number 2, pin 13, pin 1, and yeah, I guess that's it actually. But without that enable signal, these things can't even be turned on, which basically doesn't give power to the entire write circuit, which prevents it from writing to the disk, for instance, write protect, stuff like that. So let me try to figure out how this works, this enable circuit on this disk drive, and maybe I can get a little bit of clarity from that. All right, so the enable signal appears to be generated by this LS132. This is the enable signal for this drive, which is pin 14, which should be right down there. It's a little hard to probe because it's inside the bottom of the connector. Now remember, I said it's not parallel to anything on this connector, but who knows, maybe that was having an adverse effect on that chip and not allowing it to turn on. So now I can probe around here and try to figure out where that enable signal is going. A little probing around later, and that enable signal goes to 2 pins on the 2003 and all of these pins, these 5 pins on the 125. Now some of the pins are actually directly connected, like this one, but if we move the multimeter over, some of them are going through a resistor. 145 ohms for that one, 89 ohms for that one. I'm pretty sure that this pin over here is 89 ohms as well. Yep, it is. Then we have a direct connection on that pin. And these, I think one was through a resistor, 89 ohms, and then that is a direct connection. Now I mentioned if you accidentally plug this connector in backwards or off a set of pins, you can accidentally put 12 volts into chips that they shouldn't go in. And we know that that drive enable signal goes into, well, these 2 chips. So either of these could easily be damaged and causing issues. Okay, I've hooked onto the 5 volt pin. I just want to see if we are getting continuity. So we're getting continuity to that chip. I just want to see if we're getting 5 volt continuity to all of these pins, and I want to see what we're seeing on the enable signal. So that's 5 volts, 0.43 ohms. I know you couldn't see that. Same on this one. What about here? What the heck? What the heck is going on? We're not getting anything on these 2 chips on what is the VCC pin? I am confused. So one screw, this board comes out. Let's get the head off there, and we'll take off this, which I think was the write protect sensor. There we go. So this is the VCC pin for the IC that I'm not seeing the connection on. There's 5 volts. It's going down there, not there. Okay, well, that maybe is fine. I need to look at the pinout for that IC, I guess. Ground is right there. 5 volts is, that's just strange. Never mind, 74LS75 has ground and VCC on pins 5 and 12. Don't think I realized that. 4-bit bistable D-type latch. Okay, you learn something every day. Okay, so what I want to do is look at the enable signal, which I know is on this pin. Should be pulled up with like about 438 ohms. Okay. It doesn't appear that this pin is shorted to ground, shorted to 5 volts. That's what I really was trying to figure out. All right, so we don't know for sure if these ICs are working properly. I can obviously take this one out and give it a test. The 2003 is soldered on the board. Might have to socket that. When you have an Apple II disk drive that has been damaged by being plugged in incorrectly, it's usually the 125 or the 2003 that I think get damaged from that misconnection. And it's generally, I think it's because you end up feeding 12 volts into one of these pins. And you notice like the phase signals, of course, and this stuff is the front line, or it's going to be immediately damaged by that connection. Now, I guess what kind of worries me is that I'm pretty sure this is going to be connected to some of those phase signals, which it looks like is 2, 4, 6, and 8. So I clipped onto the pin 2, which is phase 0. It's that signal right there. And looking at this pinout, the input to the PROM is pins 10 through 14, well, plus the enable signal, I suppose. Okay, so that's pin 15 above the M. It's not connected to that because that's the meg ohm range. There it is right there, 470k ohm. That is going into address line 0, pin 10. All right, I'm on the next phase signal. It's probably this pin right here through 470, yep, 470 ohm resistor as well. You know what's scary about this is that means that it's possible that if this connector were installed incorrectly, that it could have sent 12 volts into the PROM. And there's no way we can get a replacement of this IC. Well, I don't see anything obviously wrong yet. So I think what I need to do is I'm just gonna put this screw back in, hold this PCB in place. I'm gonna plug this back into a computer. Let's see if it just somehow works. I mean, who knows? Maybe the speed control board was the issue, and now that that's been hopefully fixed with the recapping, this drive might show some signs of life. I'm just not gonna hook up the read-write head, and we'll just see what this does when we plug this into an actual Apple II computer. I think we're ready to test. Let's see if this does anything like lets out the magic smoke. I'm gonna power the computer on in 3, 2, 1. Oh, the light's on. And the drive is spinning. And it's spinning at a good speed as well. Is this thing actually working? Let's hook this stuff back up and put a disk in there. Maybe this will actually work. And maybe all that was needed was just recapping the speed control board, and that was somehow causing the other drive not to work. I don't know. Although I did notice that the head did not even attempt to seek at all. That's a bad sign, actually. So we might well have damage on this thing after all. So disk is in. Let's turn the power back on. Yeah, I mean, that didn't do anything. Stepper motor didn't even appear to be doing anything. Usually when it's powered up, you can't move the heads very easily. Like, they slide very easily right now. But as soon as you power up the computer, which I'll do right now. This, well, actually, you know what, is a bit stiffer. Oh yeah, as soon as I take the power off, it moves more smoothly. At least this is working correctly. And I can put torque on it and the speed stays pretty stable. So this board is obviously working correctly now. So it's my assumption if we scope the input to this, those pins on this side towards the connector, we should see the waveform as the Apple II tries to move the head into track 0 position. And I'm just gonna test one thing, by the way. The drive is spinning right now. If we flip this over, you'll be able to see that. If I hit Control Reset, yes, okay, good. It turns off and the LED is off as well. PR number 6. There we go. Okay, so speed control with the enable signal, all that stuff, that is working now. So let's get a clip onto that chip so we can scope that more easily, because I want to look at those waveforms. All right, we are good to go. I am clipped onto the phase 0 signal. And let's see if we see anything. Yes, we do indeed. Okay, there it is. I'm in roll mode. You can see those pulses. I'm hitting Open Apple Control Reset. So when I hit Reset, the signal goes low, and I let go of Reset. It pulses a bunch as it's trying to move the head, and then it ends up just staying high. And if we go on to the next pin next door, it should be exactly the same. And we should see this on all 4 of the phase inputs. Okay, so there we go, that looks good. Now I don't know what this last signal is. It's just high. I wonder if this is like maybe the track 0 sensor. So I'm going to move the head into the track 0 position. Yep, look at that. Track 0 sensor. Track 0? No track 0. So my assumption is that chip, if it's detecting a track 0, it no longer sends that phase stuff to the read-write heads. And there's one more input, which I don't think is actually hooked up to anything. So let's check the output of this chip, because when it's not at track 0, we should be seeing the output of the stepper signal. So hitting Open Apple Control Reset, nothing's happening. How do we move the head into the 0 position? That didn't do anything either. But who knows which of these are actually hooked up. So let's look at them all. Because remember, there are 8 outputs, and it's not going to need 8. It's only going to need 4. That doesn't do anything. That one doesn't do anything either. That one is dead. Things are looking bad, everyone. That one doesn't do anything either. I have a feeling this chip is damaged. And the second to last output, we are on pin 7. Let's make sure I'm making a good connection on there. Nothing. And the head is not in the 0 position, so it should be passing through those outputs. And the final output is this pin. Huh. All right, well, interesting is when I hit the reset button, I'm holding it, that signal goes low. As soon as I let go, it goes high, which is interesting. I'm on the pin 15, the enable signal, and that is just low all the time. So this chip is just turned on all the time, and I don't see a signal on here that goes low when the system is reset. I'm pretty sure the one I'm on now is the track 0. Yeah, that's the track 0 sensor. And the rest of these are the phase signals. So there it is. There's the phase signal coming through. So it's curious that pin 9, which is this one, that's output 7, it goes low when I hit the reset signal. I'm just going to remove this chip entirely. Let's quickly check to see if that signal does that same behavior when the chip is removed. I think it does. Oh, great. I can't push reset. Yeah, it does exactly that. While I'm probing that pin, I can't easily push the reset button. Apple made it really difficult to do. There we go. That signal appears to be hooked up to something else like the enable signal. Even though that is an output, although it's possible when these get programmed, maybe those can be tri-stated or something. I'm not sure, but I really feel that this chip is unfortunately damaged. And I bet it happened when this thing was plugged in incorrectly into a machine. That killed this chip since it was the frontline connection and got 12 volts sent right into it. So I'm wondering if we could just hook the inputs directly to whatever the outputs are. I just need to figure out, well, it's hard to know without a working disk drive, but if we hook those phase signals directly up to whatever they were going to, maybe that would just make it work and it would still headbang. We'd lose the track 0 sensor, obviously, but maybe this thing would start to work. So that makes me wonder if we pop this out, can I see where the traces go? Well, on the back side, no, there are no traces here to follow. So it must all be on the top side. I wonder if it goes to these resistors, maybe. Well, it appears right off the bat that all of these are pulled high through this resistor pack. And it appears to go through these resistors, probably 460K, 1K. And then it goes down, you can see the trace. Looks like it all goes down to the 74 LS75 here. So right there, right there. I assume these 4 resistors are for the 4 phases. The design is different than the Apple II disk drive. If I grab the schematic, it's different than this. This is where the phases go directly into the ULN 2003, which is that chip. That doesn't seem to be used for the phases. Or what was this chip again when we looked up? 74 LS75. Pretty sure that chip is a latch, a 4-bit latch. Now the interesting thing is this pull-up resistor from this PROM, those 2 signals, looks like the first 4 signals go to those resistors. Then these signals, well, don't go anywhere unless they go somewhere on the back side. No, the back side doesn't have anything. So those 2 must not be used. Then these 2 signals, so the last 2 signals that come out of the PROM, do make their way to other things. This goes to that via, and this goes around to that via. So it's kind of hard to know what those signals do. But I'm half tempted just to jump the phase signals right to these resistors here, and let's see if the drive shows any signs of life. And it looks like actually phase 1 is connected to write protect return. Write protect return, is that like the ground or something? Is that so the computer can pulse the write protect LED? It's an infrared LED, so it can sense it? Well, I do know that it's these 4 signals here that are the phases for the head stepper. So I'm just going to jump these over with some wire. Let's see what that does. Now jumping is complete. Okay, let's just see what happens. 3, 2, 1. No, that didn't do anything. All right, I just want to make sure that these signals are actually getting through to the little latch chip. Okay, there it was. I don't remember the other inputs. That one as well. Okay, whatever that signal is, it just goes high over here. There we go, another one of the signals. And there's the other one. So all 4 are making it through to that chip. I just don't know if that's what it wants or expects or any of that stuff. I did a quick look up. The pins that are connected to the stepper signals are these D signals. And we have 2 different enable signals, pin 13 and pin 4. And when the enables are high, the inputs, which are the D signals, just match. And when they're low, it's Q0, which I think means it's held. Okay, so this is the enable pin for 3 and 4. It just goes high, which actually is telling us that the outputs should be enabled. All right, so that's one of the outputs for the inputs that I have. That's definitely not doing anything. Let's make sure we're still getting an input. We are, although it's kind of pulled high. See how it goes up there? Could be that it's above the threshold voltage, so it just always sees it as high. Because I think the outputs, which I'm on one of the outputs there, should be actually toggling. Let's look at the enable signal for units 1 and 2. Yeah, it's high as well. Those are probably just held high all the time. Well, that's telling us there, yep, the output should be just mirroring the inputs. So I guess the question is, this 1K pull-up resistor is probably causing this issue. Which means I should just remove this pull-up resistor. Don't know if that is helping with anything right now being in the board. I'm gonna remove it. And I gotta say, I'm just sort of fooling around, and I don't fully expect this drive to really ever work again, so it kind of sucks. I wasted time, obviously, with that recapping. But I'm totally positive that that PROM that we took out is damaged, and it would have gotten damaged from this drive being hooked up incorrectly. Okay, out comes the little pull-up resistor pack. All right, there are the 2 parts that I've removed from the drive. Now let's see what the input looks like when we turn this on now without the pull-up in there. Oh, didn't do anything because while I was doing the desoldering work, I did remove the drive from the controller, or unplug the drive from the controller. I'm just going to pull this out to make sure I don't repeat the mistake of whoever might have accidentally damaged the drive in the past. Okay, here we go. Let's see what this does. Okay, well, the heads moved. They just moved in the wrong direction. Well, that's obviously because I have the wiring hooked up incorrectly, but we got a head movement. Look. It worked. Cool, so that pull-up was causing the issue. So I bet you these connections are reversed. So that pin probably goes there, and that pin goes over there, and so on and so forth. So now I have to spend a moment to try to fix that problem. Okay, there we go. I've created a little crossover arrangement. Let's take a look at that waveform, make sure it still looks correct. Here we go, 3, 2, 1. Okay, so the heads moved seemingly to the correct spot. Now we don't have track 0 sensor, so if I move that a little bit and we turn it back on, it's going to head bang. Let's just take a look at all the inputs. That one's there. Whoops, that was sounding terrible, wasn't it? And that looks good. That one there. I feel like I have something reversed. Well, they're all hooked up, but the head doesn't sound very smooth while it's operating. Let's just, I don't know, maybe that's fine. Well, maybe this thing's working. Let's hook the head up and try to boot a disk. Okay, I have a floppy disk here. Let's pop this in. Let's see if this can actually read anything. Well, it's not reading anything, that's for sure. What's interesting is, yeah, while the system is powered up, the head is not easy to move. But it's also not booting. Wonder if one of the other signals that was coming from the chip I took out was actually allowing some other parts of the drive to work, like to read a disk or something like that. At least we're getting more signs of life out of this thing than it's ever given us, right? Now, one thing we can try doing is trying to look at the read signal as this has a disk inserted, and let's see if it's actually outputting any data to the computer. So I'm trying to figure out where exactly to pick up this read signal, because I don't see anything coming out of there's nothing going to the computer. So that's why it's not able to read anything. But I'm trying to figure it out on the amplifier. Now, on the actual Apple II schematics, the 3470, which is this IC, pin 10 is the output of the read signal, and it gets buffered by the 125. So let's see if that makes its way to the 125, which is here. Yep, It does. It goes right there. What pin is that? That's pin 9 on the 125, which it goes to 12 on the original Apple II drive, but it might have changed. So the pin 9, the output of that goes to pin 8. Theoretically should go to the read pin on the Apple II, and the machine is turned off right now, so we'll pop the controller out. Read data is pin 16. Yep, that's it right there. That's going to pin 16. Could be that chip is bad as well, but I don't think so because I'm not even seeing the output coming out of this chip. But let's just double check with this thing running. I think the heads are bad on this drive. I don't think it's actually reading anything because I am not getting any signs of life out of this thing at all. I'm not seeing any data. We should be seeing some waveforms on here in oscilloscope mode, of course. Now the output of this is 5 volts, peak to peak, and the drive is spinning and the heads are engaged, which means it should be reading data and sending that to the computer because the drive is turned on, it's spinning. I mean, the heads are plugged in, but we're just not getting anything. And it was this one here. So the input to that gate is 9. I mean, imagine that it's pin 10 here. This goes to pin 9. So the output of the 3470 should have data on it on pin 10. And it's got nothing on it. Nothing at all. And we should be seeing something. I mean, this drive, the heads are engaged. The pad is pushing on the disk. There's just nothing at all happening. Something's damaged over here. And the read-write heads on the Apple II disk drive, they go into pins 1 and 2 on this chip. I mean, there's just nothing, absolutely nothing. If we unplug this, yeah, we got a little spike of something. Just making sure it's a nice firm connection. And it is. You know, these are gold pins. This cable here, it's in good shape. And as you can see on the scope, we're getting nothing. So we made progress with this drive, but I'm pretty sure the heads are damaged or not working. Let's see if there's any kind of enable signal on this chip. I'm pretty sure there isn't. At least on the Apple II drive, there's not. This chip is just on all the time when the drive is powered up. Yeah, it's not connected to anything except the read-write heads, and then the read signal output, and then 12 volts, minus 12 volts, which is this potentiometer right there for adjusting the differential amplifier. It looks like, yeah, we got another 5 volts there, test point. Yeah, there's definitely something wrong here. Now for writing to the disk, the write data, it goes into the other chip there, the CA1 or 3146, and that's a CA3146 as well. So that's this IC, so that handles the writing. I'm really feeling the heads are just open on this drive. And unfortunately, we can't see them. That plate's in the way, the wire connections. Heads aren't dirty though. There's a felt pad that pushes on the disk. That's necessary. Let's check the resistance of the heads. There are 5 wires, about 4 ohms, 4.2 between white and yellow. And over here, 33 ohms. There's a black wire in the middle, which I assume is ground. Don't think that's going to be connected to anything. No. Yeah, that must be like a shield cable probably. Yeah, 2.98. How about to the other pins? 17, 12, 13. I mean, I don't know. These numbers don't seem bad. I would think if we had stuff that was like way up into K ohm or meg ohm, that would be the problem. I'm going to pop this chip out and I'm going to plug the heads in the way I think they should go on, which is this way. And I'm going to measure the heads directly, the waveforms on the heads directly. Because maybe there's something wrong with this chip and it's like pulling the signal down coming off the heads. Because the signal on the heads, of course, is very low amplitude. I would just expect to see something besides that. I may see coupled, that's why the waveform is moving slightly. None of these wires are doing anything. If we change this to DC, see what the bias is. It's like maybe 12 volts or something like that. Which actually, now I think about it, what if it's somehow getting stuck in write mode? And what we're seeing is it trying to write to the disk. And the reason why I say that is with the chip removed, I wouldn't expect to see any bias. I should remove the LM3146 actually, and I want to see then if that if we start to see a signal coming off the heads. Because obviously right now we're not trying to write to the disk. I wonder if that's erasing my floppy disk, to be honest. It might be erasing my disks. It's okay. Both of the disks I stuck in here were not important. I can make new copies if I need to. All right, here's the chip, the LM3146. That popped out pretty easily. I didn't even have to use hot air. All right, here we go again. Let's see if we see anything on the read-write heads. I see nothing. It's like they're not connected at all. Put back in the 3470. Let's see if that makes a difference at all. No, there's just like nothing. There's nothing happening on this drive at all. Let's try to move the heads. I'm going to force them into a different position. Here, I'm going to go down to 200 millivolts per division and look at the inputs to this, to the heads. There's just nothing on there at all. Still getting 3 ohms, and that's with it even connected. And on the other two, yep, similar to what we were getting before. Yep, nothing's really changed. I want to just add a little bit more clarity. This is the CA3146. It's split into 2 parts, and it turns out that this chip only just has some transistors inside. It doesn't really have any other logic. But I briefly showed that when I removed this chip, the 12-volt bias that was on the read-write head just disappeared altogether. I think what happened when the 12 volts disappear when I removed that chip is because the erase head, if you follow this trace, goes through this transistor 2N3906, and that is connected to the 12 volt rail. This is the 12 volt rail right here through that transistor, which gets turned on when the enable signal turns on through the ULN 2003s. That turns on this transistor that connects 12 volts to this transistor, and if this transistor gets turned on, then the erase head gets 12 volts. And when we measured the impedance of the read-write head, all of these lines are actually connected together. There's just like different resistance values, but that means that the 12 volts, if it shows up on the erase head, will also show up on these other 2 lines. At least I think that's the case. And when we take a look at 3146's section down at the bottom here, see this transistor right there, 8, 6, and 7? Well, that is what goes to the base of this transistor and connects that 12 volts to here. So when I remove this chip, it removed this particular signal here on the base, and that disconnected the 12 volts from the read-write head entirely. And what controls this transistor that's in the 3146? Well, that signal goes here through this diode, through this resistor, through the ULN 2003, and it goes to the 74LS125, and then to the write request signal coming from the disk controller. Just keep this all in mind as I continue through the troubleshooting. Well, since we've been looking at the drive schematics for the actual Apple drive, I went and grabbed an Apple drive, took the cover off, and yeah, it's very similar inside. We have a few less ICs, but it looks like right there, that is our read amplifier 3470, and perhaps everything we're seeing here with nothing from the heads is entirely due to the chip in this drive being bad. Now, I did figure out though that this drive absolutely without a doubt erased my disks, so it was like stuck in some kind of write mode. That's that 12 volts that I was seeing. Well, now that the write chip has been removed, I don't think that's causing any problem. The LM3146, which this drive has as well. So we can always borrow this from here to test in there. But the first chip I want to test is this one here. I'm just going to put dots on all the original chips that are in this drive, since it also has a 2003 and it has the 120 LS125. Okay, so here's the chip from the working drive, the read amplifier. Let's pop that in, see if that makes a difference. The disk that's in here, though, I think is one that's been erased. Oh, no, I rewrote this one. I think this drive or this disk should be working now. All right, let's turn this on. Let's see if this does anything. No. So the output is on pin 10 again. Let's take a look at that. Oh, you see that? There's a valid signal. We actually have it reading the disk right now. It's not booting, so it's still messed up. Now I know that chip was bad as well. Now I'm pretty sure, in case you're wondering, that the write amplifier is not needed to actually read any disks, because there are 2 diodes here that stop this stuff from happening. And let's just see what else is going on here. I mean, honestly, I wouldn't be surprised if the LS125 is our next problem, because that definitely is buffering, well, all of this stuff for the read and write. Oh, you know, well, and actually we can just check this, because I think the input into that chip is pin 9 and the output is pin 8. So that is 9 would be right here. Okay, so hopefully you can see there's stuff there. That's the input into the LS125, and then the output is pin 9, and that would go to the computer itself, and there is nothing. Now this has to be turned on. Pin 10 needs to turn on that particular gate. So let's look at pin 10, see what it's doing. So the heads are good on this drive though. Pin 10 is low. And if it's anything like what's happening here on this schematic, it happens to be a different gate, but same chip. Read data, it's gated by pin 13 here, but we know it's 10 on this drive. That signal comes directly from the enable signal, and it's enable low. And what I mean by is enable low, when the drive is enabled, the signal going into the drive is low. And that's what we're seeing on pin 10, and yet we're not seeing any output on this IC. So it is my assumption that this IC is damaged as well. All right, so here's the one from the Apple disk drive. And let's take a look at pin 8. So this is the output that goes to the disk controller. I need to be able to hold this and turn on the computer so I don't block the screen. Here we go. There it is. Okay. Well, it obviously started to boot, but I think this disk might be bad. Okay, I think it gave up, so it stopped. But you saw it actually working. So both of these chips were bad. That chip was fried. And I suppose maybe these two are working. Now, I don't know if I have the motor phases or the stepper motor phases hooked up correctly for the head. So maybe it's not quite seeking correctly. But this is a perfect opportunity for us to hook up both drives, and I boot Locksmith, and then I can really check to see if the alignment and what's going on with this stepper motor here. I don't think it's out of alignment, but who knows if these phases are getting through correctly, so maybe it's not stepping correctly. That is awesome that this drive is showing signs of life. That freaking is working. Not quite, but nearly there. I was so sure that the heads were bad because I just expected to see a signal there, and I wasn't. Now, the weird thing is, without a doubt, we're obviously not going to be able to write to this disk at all. And I'm scared because if I put this chip back in here, it's going to have the tendency just to erase the disks entirely, because it absolutely, without a doubt, erased this disk that was in there before when I was doing testing. That 12 volts was activating the erase head. I think it was, at least, and seemed to be erasing stuff. Right, so when it comes to these bad chips, I have this Apple II disk drive, which is a very interesting one where you click down and click up the mechanism. And it's a cool Chinon drive. And Chinon made the entire drive. But this drive has a really annoying problem where if you turn off the Apple II, while a disk is clamped in there, it erases this what's under the head. And I corrupted many disks with this thing. And of course, people have heard plenty of stories of like, you should always open the drive before you turn it off. Well, it's because of drives like this. Well, I've opened this thing up and I don't feel bad stealing the chips off of this board to fix this disk drive. If we can get this one working. This seems to have a good number of the chips we need. It has the LS125, it has the 3470. Does it have the right amplifier though? It seems that it does not. The design of this drive is actually kind of different. I think it's using these transistors over here for writing to the drive or writing to the disk. Well, either way, I'm stealing those two chips out of this to make this Apple II disk drive work again. And I'm doing that because I've never used this drive anymore because it's too dangerous for me. I've ruined, like I said, plenty of disks, and therefore I've taken this thing out of service. So I'm just gonna take those chips out entirely, and well, that's gonna maybe save another drive that can maybe work. And if not, I can put them back in here. It's interesting that all three chips that were in sockets are damaged. And I don't know for sure if the right amplifier is bad, but the three that were in sockets are bad. And I wonder if they put them in sockets because they knew they could easily get damaged in cases where someone messed up the connection to the disk controller. Interesting. All right, I'm moving this disk drive to the second position, and I'm gonna plug the original Apple drive, which I reinstalled the two chips into drive position 1. And we'll install the two chips I just took off the other drive. Okay, they are now installed in this drive. When we turn this on, this drive should start to boot. Here we go. Yes, it's trying to boot, so we're not having the issue we were having before. And I will grab the Locksmith disk that I just made. Okay, stopped trying to boot, which I think means Locksmith loaded up. So I think we do utilities and we do 16 sector fast verify, and we're gonna do drive 1, which is the disk, well, the Apple disk drive. It's very noisy. but it does work. Oh, okay, whatever. We can ignore those. But now we're going to do disk number 2, and I'm going to put this locksmith disk into this drive. Let's see what happens. Okay, it's kind of working. It's kind of reading the disk. Now I'm wondering now if it's this potentiometer I need to adjust, because I think what's going on now is I've switched out the 3470 and maybe that's the issue. So let's turn this. Oh, you know what? It's just working. There's glue on there. I didn't even turn it. I think this is reading even better than the Apple drive. It was getting like a few bad sectors in there and none. Now, of course, it goes without saying, this will not write to the disk whatsoever, right? It can't. The chip is missing. Just for grins, I just hooked up the write protect switch. It's not going to make a difference. Now, I'm wondering, everyone, if this chip for writing is not damaged, and the problem we were having with writing was the LS125 that was not right. I mean, it's just working. It's just freaking working. I still can't believe that it's working. I was ready to write this drive off entirely, and it's working. All right, let's go back to our little friendly schematic. So this is why I was thinking there was an issue with the write circuit, because it relies on 2 of the gates. Oh no, it's actually relying on the ULN 2002, but it's relying on 2 of the 125 gates to actually turn on this entire part of the circuit, the write circuit. And I'm wondering if that is somehow messed up. But of course, the ULN 2003 could be bad too. But the 2003 on this drive was probably saved because it wasn't connected directly to these lines, right? That was the PROM that got killed. And it's also kind of behind these gates here. So these are connected directly to the connector. So they could have got 12 volts. But I think the 2003 is probably okay. So this chip's probably okay. I just need to put a socket in the drive and then maybe reinstall this, and we'll maybe be writing again as well. I just don't know what these extra 2 lines out of this were doing. And I'm wondering if that's somehow going to prevent the writing from working. Just for fun, let's try to format this disk. It's the one that already got erased. In fact, watch what happens. If we pop this in here and we try to read that drive, it might have some data on it that's valid. I don't think all of it got erased. It only got erased like where the heads were over the disk. So we might end up finding that there's some parts of it that are okay. I don't know, a whole lot of it's messed up, but that's probably because the head was seeking, you know, as I turn on the computer, but it was writing to the disk even as it was seeking. So I think it kind of screwed up the whole disk. Yeah, some more blank parts there. Oh, super funny. You know, it was erasing it in a spiral, and you could actually see that spiral pattern there. And that was the head seeking across the disk. Okay, well, anyways, the disk is erased, but no big deal. So I'm going to do this and do 16 sector format, and I just want to see what this is going to do. Output drive 2, start track, yep, we'll just do the whole thing, and that's hex track 22, by the way. And let's see what happens. I mean, it's not complaining about write protect, which is interesting. So that was basically a big fail. It didn't actually do anything. So if we try to verify the disk, it's going to look exactly the same as it did before. It wouldn't have written anything to the disk because that chip is out of the drive. Now I'm just making the locksmith disk write protected, because what I want to do is I want to try to format this disk in drive 2 with the write protect switch on. And I want to see if it can even detect that write protect is set. No, it cannot, because if we try to format drive 1, let's see if we get the write protect error message on this one. Oh, no, we don't. I don't know if the Apple II can even detect write protect. I think it can, because write protect is a signal that makes its way to the drive controller, but I guess this thing doesn't actually look at that. I don't know. But the drive itself can't write to the disk when the write protect tab is covered up. All right, well, I'm going to pop this chip back into this. I'm going to put a socket first, of course, and then we'll put this back in there, and we'll see if this drive can now write, and then it might be completely fixed, maybe. Okay, the socket's in, chip is back in. Let's turn on the computer, and Locksmith has booted up. I'm going to put in this disk that's already trashed. Let's just see what it does exactly. Utilities, verify, disk 2. Okay, this is good. This is good. It's doing exactly what it was doing before. Like, we're going to see those spirals. They're going to be this way. And you know what? I was going to hook up the oscilloscope, but let's just do a format on that disk. Format, disk 2. Let's see what happens. I have no idea if this is actually writing to the disk right now or not. The only way we can know for sure is do a verify. No, it didn't actually write anything to the disk. So our format process failed. So if we do format, and I'm going to do drive 1, but I'm going to switch this floppy, the trashed one, into the other drive. Let's see if it can write to the drive or write to the disk properly and what it looks like when it formats. Ah, it draws an F. That tells you it's actually formatted the disk. I think we're going to be able to figure this out. I think we're missing a signal, and now that the LS125 is fixed, because I stole it off that other drive, I have a feeling the right amplifier is not getting exactly what it needs to turn on the right signal. There's a lot of protection so it doesn't accidentally erase a disk. I'm just going to verify that this disk that we just formatted in here looks good and nice and blank, so it's no longer trash. Yep, it looks good. Now I'm going to switch this over to the other drive here. Let's make sure it can actually read this disk. Format, drive 2. I wouldn't be surprised if this Apple drive is slightly out of alignment, and that's why it had a few bad sectors there. Let's just try that again. Yeah, it's having a bit of an issue. Yeah, I think that Apple drive probably needs a little bit of TLC when it comes to its perfect alignment. But the main point is the disk controller in the computer is able to tell the disk drive to format the disk. So now we need to probe these signals that are going into this IC, and we can use the schematics for the Apple II drive just to see exactly what is necessary for it to all work. So we have write data, write request. This is a low signal. And we should be seeing that signal. It goes through the ULN 2003. I don't know if it's on the same gate though. And then that should make its way over here. This is the 3146. But I'm trying to see where that goes. Okay, that goes into pin 12. That's a gate on pin 12. Let's look at pin 12. And when we try to format, I'm assuming that should change. I don't know if it's low or high, but it should change. Okay, so we're looking at pin 12. Let's start the format process here. Here we go. Well, that didn't change at all. Now, so there it is, pin 12, that's the gate, and that is connected right there. It's also going to pin 6, actually. It's going to 6 and 12. And that is coming out of the ULN 2003. And I guess we should look at this write request line, because actually now I think about it, we need to make sure that this is allowed to be turned on, because look at the whole write protect circuit right here. Okay, actually, yeah, we need to make sure this is being turned on, because if the drive thinks it's write protected, it's never going to turn on this part of the circuit. And that's what I think the problem was before, is that these LS125, that since that was a bad chip, it must have always been turning on the right circuit, which is why it erased those disks. So write protect, there's write protect. It comes down here, goes into that gate. So it goes to pin 20 on the disk controller when the drive is enabled. I'm going to have to spend a moment just to trace out how pin 6 and 12, like which gate on ULN 2003 they're going to, and then where they're going on the 125, and then where they're going on the connector on the card. All right, I figured out some stuff. So the write request line comes into the 125 on pin 12. It comes out on pin 11. 13 is the control gate for that. It goes into the ULN 2002 on pin 5, comes out of that on pin 12, and then I had to figure out where these components were, like this resistor and that diode. And well, basically the output of that is what goes to the gates of this. So we need to take a look to see if this is being turned on. So we need to see activity on 13 when we try to write to the drive, because if not, this gate, we follow this up here, this is controlled by the write protect right there. And this part of the circuit might be messed up, because it's quite possible maybe it was like something to do with this. Remember how there was these 2 extra signals right there? So let's investigate that. Okay, so first we're going to start with pin 12. This is the write request line. That should go low as soon as I hit enter. And actually, if we look at pin 11, the output of that, that is just high, which I think is correct. And then pin 13, that's the gate signal. And actually, that's not really even low right now, but I guess 2.5 is just what it is. I'm going to hit space bar. Disk is write protected. Interesting. So I did a different thing. I did erase disk, but that was able to sense that the disk was write protected. So I'm going to try the other one where I'm going to do format F, and I'm going to be writing to the drive that works. So output drive 1. I just want to see what this signal does. Oh, I see. It only goes low when it's actually writing to the disk. Okay. All right, well, what I need to do now is I need to try to figure out the write protect signals. We know that's our problem, right? So I need to look where pin 20 is, what it's connected to. I hate how the pins are all swapped around just arbitrarily. It's just so silly. Okay, the write protect signal is pin 3. So that's the output of this drive is pin 3. Oh, that's shockingly, that matches pin 3. So the input is from pin 2, and that's what I need to try to figure out why this signal right here, this pin 2, is not working correctly. Meaning it's always thinking it's write protected. So I'm currently looking at pin 2, which is the input to that gate, because that gate, it only gets turned on, well, when the drive is enabled. Turn the computer back on. It's just got 5 volts on it, and we take the disk in and out, that doesn't do anything at all, right? So it's not even knowing that the disk comes out or goes back in. What is this down here? Is this the write protect sensor? What's that hooked up to even? The traces kind of go over here. Let's turn the power off and investigate. Kind of looks like an LED, but I bet you that's not. I bet you that's the actual sensor itself. Well, one of the 2 wires, the red wire from the write protect sensor, goes to the pull-up resistor that I removed. It used to be driven from the PROM that was in there, and it's not any longer. So this right here, yeah, goes there. All right, well, that means that sensor never gets any power. So my assumption is, I guess it was coming off of phase 1. Huh. And the write protect, this is the other part. That's what I was measuring. Pin 2 just seems to go directly to write protect. But yeah, it's the return. I just don't quite understand how this is supposed to work. I'm going to try to find the other wire. Okay, so it goes to that. This is the other wire. What does that go to? So it goes there. So it's going to something around here. Oh, there it is. It's on this resistor. What does this resistor connect to? This transistor, maybe? Yep, it connects to that transistor. So that's got to be part of the circuit. All right, so maybe what's going on is I need to feed 5 volts into this, or at least connect it to phase 1, just like it is here. Okay, so I don't actually know which is phase 1, so I'll have to unplug this again. Phase 1 is pin 4. Okay, so phase 1 is the yellow wire here. Now, one of the issues is on this drive, it goes through these resistors first, because this was originally going into that this chip here, the PROM. So 460 ohm. And I think the problem is I got to drive that signal directly off of the phase coming from the disk controller to activate the write protect switch. So that means, let's figure out again which resistor it was. Okay, so it's that second one. I'm going to have to run a wire. I'm just going to draw a little mark on there so I can see it. I'm going to have to run a little bodge wire from there over to, let's see here. I think it was, where was it? Is this trace? No. Yeah, over to this trace right here, the one I have the black probe in. So I have to run a wire from there to that resistor, a little bodge wire. I think that might make this work, maybe, or it'll break everything. That's quite possible too. Right, so the little bodge wire should be going from pin 4, which is the right phase wire, right to here now. I don't have that on beat mode, but that was full continuity. So it's kind of looking just like this. So it's coming off of phase 1 and it's going to what was write protect return. Don't know if that's correct or not. It's the red wire on this thing, but who knows? I don't really know what else to do. I don't know what the signal looked like that came out of that PROM. I never had a working PROM. And by the way, I checked the MyTAC drive. It doesn't use a PROM. It just uses TTL logic to do the same thing that this drive used a PROM for. Okay, here we go. Let's turn this on again and see what happens. Okay, system seems to be working. I'm going to boot Locksmith on the other drive. So I'll pop the disk in. Well, I'm going to look at the sensor here. I'm going to hit erase disk. And we'll do drive 2. Oh, there was a signal on there, so yeah, it was doing something. But let's look to see what we saw on there. But let's check pin 2 here. See if we have anything here. So let's do that again. Erase disk. I mean, it certainly had a signal there, but it still thinks it's write protected. So I'm picking it up off the LS125 pin 2. Yeah, it's the input of the signal that goes to the computer, the write protect signal. Pin 3 is the output, which is currently low. So if we do erase disk and we do drive 2 again. So, you know, we saw a signal there, but I guess it's maybe inverted and that's not making it happy. So I'm going to check pin 3 again. This is the write protect signal that goes to the computer. I mean, we see occasional pulses, but it is my assumption that pin 12 here, yeah, it's never going to actually show that it's trying to write anything. Yeah, this is the output that goes to the right amplifier, and that does not work. Let's do that again. Yeah, I mean, there's nothing happening there. And the input to this chip, I'm sure there's nothing. Well, I guess it's high, actually. Oh, it's inverting. Okay, that's normal. Okay, I'm looking at the output of pin 11 on the LS125. Let's see what that does. Nothing. So that's why, of course. Oh, there is a... It does do something, actually. Yeah, I'm at a loss. I think the issue is that the circuit that was originally in this drive with that PROM maybe used the signal inverted, or it didn't pulse, or who knows? It's obviously a different, slightly different design, and I don't think I can replicate it by just simply adding a single bodge wire like I did. The only thing I can think to do is maybe move that bodge wire to one of the other phases, see if that somehow magically makes it work a bit better. I don't really fully understand the way the circuits work. I just moved it to one of the other resistors here just to see what that changes, if anything. You know, I'm kind of thinking maybe I should just move this wire to 5 volts, and that might make this work all the time. Like it would just, the write protect switch won't work anymore. I don't know. Okay, I just moved the wire to 5 volts directly. I mean, when this chip was in there, there was a pull-up resistor to 5 volts. So it would obviously drive it to 5 volts sometimes, drive it to ground other times. It was mostly grounded, connected to the phase wires. I don't know, I'm just totally guessing at this point. I'm gonna turn this on again. Okay, erase disk. 2. Oh, it's working. It's actually writing to the disk, I think. I don't know, we'll have to do a verify pass. What? I just did not expect that to work at all. So verify disk 2. Oh, yeah. That did not work. But it didn't look like it actually wrote anything to the disk. Let's try that again using this format. Okay, so wait, we're getting Fs. Oh wait, maybe erase disk doesn't actually apply a format. It just turns on the erase head and just erases it or something like that. But the fact that it's giving Fs now instead of asterisks is a good sign that this actually might be working. I cannot believe that this actually might work. I cannot believe it. Let's see what happens. I am shocked. Shocked, I tell you. Here we go. Verify. Disk 2. Oh, it actually wrote to the disk. It freaking wrote to the disk. You're kidding me. So while editing the video, I was just giving some thought to why Apple designed the circuit originally like this, where the write protect signal seemed to be connected to phase 1. I think what's happening here with the original circuit, which is clearly not the same as what's in this drive, because this uses a whole transistor and an optical sensor. I think the original Apple II was using an actual physical switch that when you actually inserted a disk that didn't have the tab on it, then the switch was able to activate. And what this must be doing is that whenever the drive is actually actively seeking, so the head is moving, that actually turns off the write protect circuit, or essentially makes the disk write protected anytime the drive is seeking, probably as a protection mechanism, because obviously if the drive is seeking, you would never actually want to write to the drive if one of these ICs were bad, for instance. Now, I think that's a little bit overprotective, and the reality is for this drive, I just hooked up the write protect directly to 5 volts, and then it has a little transistor that then drives this gate at the LS125 and tells the computer that the thing is write protected. And in addition, whenever the write protect is not set, meaning you can write to the disk, this is where the signal here, this little plus or this cross is where the signal goes down to this gate, which allows the write request line to be activated, which turns on the entire write circuit and writes the data to the disk. The only thing we're going to be missing here is that while the drive is seeking, theoretically, if there was a problem and these signals were enabled, like write request were low, then it could erase your disk. But it wouldn't erase it if you had the write protect sticker installed. That would disable this all the time. It's just, I think that's why this was designed this way in the first place. And this whole phase 1 thing kind of got me off track, thinking I need to hook up to that. Well, here's a good test. We'll do a backup copy. So this is going to copy the locksmith disk onto here. And if it actually is able to do that, and then we'll be able to boot to it, then we'll know this drive is actually writing to the disk. I am shocked this drive might actually be working. I mean, really shocked. Right, okay, it finished writing. So we're going to take this out, pop this into the Apple II disk drive, and we're going to reboot the computer. Oh, it freaking booted! It booted! It's crazy. This, I just can't believe it. I can't believe it. Verify, drive 1. Oh, well, it booted, but certainly not, it's not reading very well. I'm surprised it was able to boot with all this garbage. Now, again, this might be the Apple II disk drive. Let's pop this disk back in the drive. It just wrote it. And we'll try verifying it in this drive. So it's able to verify itself. Now, where's the alignment problem? Is it the Apple II drive or is it this? It's more likely to be the Apple II drive, frankly. And I say that because this disk here, I wrote this in a 360K modern floppy drive on my PC. And I think if we do a verify pass on this, this will actually read perfectly as well. So that kind of tells us that this is close enough to my Fujitsu drive up there that it's able to read all the tracks, but it actually wrote to the disk. Now here's the question. If I try to format this disk with the write protect tab, is it going to just ignore the write protect tab or will it actually work? Let's try that. So we're going to do format, drive 2. Here we go. Yeah, it's showing an asterisk. I don't think it's actually erasing this drive. That means this drive is actually working and the write protect tab is being honored. You gotta be kidding me. We'll know pretty quick if I try to put this locksmith disk into the other drive and reboot the computer. Will it actually boot and work? It boots still. It totally freaking works. This drive is fixed. Unfreaking believable is all I could say. Unfreaking believable. Now we have some things we can do like disk speed, and we can run this on this external drive. I'm going to do optimum drive speed for drive 2. And I don't know, we'll do fine adjust, number of samples per line 2. And let's see what this does. Okay, so it's a little slow, but it's also very stable. Wow, that line is just perfect. I could tell you if we run this test on the Apple II disk drive, which has a belt and everything, it's going to be all wobbly and all over the place. Let's try to fix this. Guess I can turn off my oscilloscope. I don't need this now. And I'm going to carefully turn this on its side. It might alter the speed a little bit. Wow, just a tiny bit. I'm going to get a very small little screwdriver to adjust the speed here. Oh, slowed it down. Just the tiniest turn of the potentiometer. Oh. Right on the middle line. You can't get much better than that. You don't even see it doing anything because it's so stable. The speed of this drive is so absolutely stable. That's actually, frankly, unbelievable. Yeah, moving the drive made it move around a little bit, but look at that, right back on the middle line. And we're in the fine adjust mode, not the coarse adjust, the fine adjust. Let's put this disk here in the Apple II drive, and we're gonna do disk speed in that thing, and we'll do optimum again, output drive 1. It does erase your disk, so just be careful. And we're doing fine adjust, 2 samples per line, Let's see how unstable this thing is. Oh yeah, that is more what I would expect from one of these drives. It's all kind of wobbly and all over the place. Let's see if we can adjust this though. The speed adjustment on this drive is not accessible while it's mounted in the case. But that noise is typical for belt drive disk drives like this Apple II disk drive. It'll drift and get slower and faster. It's fine. It's obviously close enough that it like boots this program and everything. It's not really an issue, but I am blown away how accurate the drive speed is on this thing. I guess that recapping absolutely worked. Okay, so at this point, even with this disaster and this drive is now fully operational. All we needed to do was swap out that chip, swap out that chip. These are all original and they're fine. And then we just had to do this bodge there and this drive works. Track 0 sensor just doesn't work anymore. Oh, and of course, recap it. So I'm going to put this back in its original case and we're going to try to boot and play some games on this machine with this disk drive that I thought was totally dead. All right, the Distar drive is all back together and I cleaned it up a little bit. It all fits back in, even with the sockets I added and whatnot. I have something on this trash disk. I wrote it on my grease weasel. All right, let's turn it on. Sure is loud. But it works. It's working. I'm dropping things on the floor here. I haven't tested this disk image. Sometimes grease weasel doesn't always write perfectly. Still reading, so I assume it's working. There goes the Buick Dimension. Press any key to begin. All right. Now I could only write side 1. I couldn't write the second side. Uh-oh. It was headbanging there. Abort. Let's just do a test, a RAM test on the 2E. All right, system okay. Well, while we're waiting, I'm going to insert the other disk, which is the thing that I always have to test whenever I do Apple II videos. The headbang is so loud on this drive. Let's see if it can load this. Uh-oh. It's not working. And I used this disk the other day on the MyTac drive and it worked. Oh, it worked. Okay, it's still loaded. Fat City. Very nice, very nice. Give me my disk back. Well, I don't know where I wrote this Fat City disk. I'm gonna have to image it and make a new copy, but I just made this fresh disk in that drive, the Grease Weasel. Let's reboot. It's so loud. But hey, it works. Droll. All right, all right. See, this is loading perfectly. It could be that my Fat City disk is not working. Hey, there it is, Droll. Good game by Broderbund. Can I remember how to play? Okay, how do I go up and down? Okay. Oh. Okay, gotta get to the girl, gotta get to the girl. Ah, oh, okay. That is my Apple IIe, that's this computer. And it's got this really annoying fault where if you bump the computer, occasionally it crashes like this. And I've tried to fix it, and it usually does it like one time, like once, and then it never does it again. And believe me, I deoxidated all the sockets. That didn't help. So I don't know if that's worthy of a repair video or not, because I don't even know what to do with this thing. I deoxidated everything, but it's obviously got a bad connection in there. But it's so intermittent when it happens, like you saw, just that one time. Let's see if that does it again. I don't know. Maybe it crashed the game. I was about to finish the level too. Oh, okay. Gotta get the girl. Whoa! No! Oh, this. Okay, yeah, you got to get the girl, and you got to get the other thing that I picked up. Oh, it's right there, overlapping with one of the lobster things. I don't even know what they are. This game's quite fun though, and I remember as a kid, I really loved this game, and I was better at it than I am now. But remember, I'm playing through OBS, so there's a serious delay on capture. So I'm making excuses. Okay, I like when you shoot that bird there that was flying, it turns into a turkey, and I always love that. Okay, you got to get that guy first. Him. Okay, now we got to get the girl, wherever she is.
game works perfectly on an Apple II Plus. You know, I think she's on the map, but I don't know what she looks like. So where is she? Yeah, notice it's not crashing now. It's just, yeah, I did it like once earlier today, but this machine is otherwise perfectly stable. There she is. I think I'm gonna just swap the motherboard because like I have other Apple IIe motherboards and I might as well just do that. And I love this case. This is one of the old original 2E cases. It's more like an Apple II Plus case. And then it also has Alps keyboards. So it's like very, very good quality. This level is much harder. Oh, yeah. Bye-bye. Got to go away from them. Oh, there's the boy. That's it. I can finish the level. Oh, come on, boy. Come here. Yes. Level 2, level 3. All right, yeah. Anyways, this game's fun. And notice the disk drive's working perfectly. So I think Fat City, that disk is just getting kind of crapped out. Oh yeah, this level's much harder. The game ramps up in difficulty quite quickly. Okay, well that is a successful repair of this disk drive. And I have to tell you honestly, I was ready to give up a number of times and just say that this thing was going to be a parts drive and never work again. But in the end, I bodged it together where it's working. And it's sad that we don't have we lost the headbang protection that this thing had in it, but the PROM chip got wiped out by someone, connecting this up the wrong way, and along with those other two ICs. And I have to tell you that I honestly was ready to give up on this disk drive a number of times. And in fact, earlier today, because I was wearing the same clothes, I did give up on it. And I was going to edit the video, I edited it up, and then I thought, you know what? Maybe there's a few more things I should try. And I came back down and I started trying those other things. I had a whole outro where I was just like, it's broken, it doesn't work. And I am shocked that this drive is now fully functional. I wasn't sure if I'd be able to figure out the whole write protect thing, but just hooking up to 5 volts suddenly just made that whole circuit work. And yeah, it works. So I hope you enjoyed that troubleshooting exercise. I have to say, like, having these original Apple II schematics for the floppy drive helped, even though this thing is obviously different and took quite a bit of like reverse engineering to kind of figure out what the pins were on these chips versus on the schematic. Still was absolutely worth it to have that schematic. And analog circuits, especially really cleverly designed ones like Steve Wozniak did on this, well, it's a bit of my arch nemesis because I don't really know what I'm doing there. But in the end, we got it working. And now I have 2 working drives. Now, as for this other drive that I stole parts out of, don't be sad about that drive. Like I said, that was a Shelf Queen drive. I'm just going to put that back together and put a sticker on it to say, not usable, missing parts. I could obviously restore that back to original just by putting those chips back if I get some more of those chips. But the reality is that drive has a write circuit that's just badly designed. It's obviously different design than this and didn't even copy the original Apple II design, because this thing does not have that problem of erasing your disk if you power up the computer. But that drive absolutely does. And the worst thing about that drive is even when the disk is write protected, it still does it. So there's something in the write circuit on there that like pulses when you shut it off, and then it erases whatever's under the head, even if the disk is not spinning, because it's not when you shut the computer off. So definitely sucks, and I ruined a few original discs with that drive. So yeah, don't feel sad for that thing. Like I said, Shelf Queen, it looks cool because it's a squishy mechanism. I like that, but anyways. All right, wow, this was quite the fix. I'm amazed at myself that this is working. When I sat down to make the repair on this drive, I thought it was gonna be an easy repair where I just had to like swap a chip and we'd be up and running. I didn't realize this drive was gonna be quite so much work. If you like this video, thumbs up. If you didn't know what to do, huge thanks to my supporters. Names going up the side of the screen. Subscribe, like, all that YouTube stuff, and that's gonna be that. So stay healthy, stay safe, and I'll see you next time. Bye.